This is a fairly intense problem involving some power reducing identities. Now, the first two equations on the left, the sine squared and the tangent squared, don't usually cause any big problems, so I'm going to breeze through these fairly quickly. And then we'll get to the cosine to the fourth problem last, and that's where most problems are. So if you look at this equation that I've got right over here, okay, this thing simply says that if you have the sine squared of something and you want to get rid of the squared, you replace it by this smaller equation, well, with this larger equation, I guess, with the cosine 2a. It doesn't have any squareds in it, and that's the important part. That's what we want to rewrite this as. So I'm going to rewrite this simply as 1 minus cosine of 2 times the angle. Now, what's the angle? What's the a in this example? It's going to be 3 phi. So I'm going to write 6 phi, right? It's twice the original angle. And that's the answer. It's as simple as that. Second example, same sort of thing. If your original angle is a, then you write it as 2a when you use the power reducing identity. But in this case, it wasn't a, it was 7 phi. So I'm going to say 1 minus cos, whatever 2 times 7 phi is. So that'll be 14 phi. Okay, minus cosine on top plus cosine on bottom. So that's how these things work, and they're fairly simple if all you've got to deal with is a squared. But when we're dealing with the cosine to the fourth, well, now it's kind of time to put on the big kid underpants with this one. So what I want you to do, first of all, notice that I just plugged in the power reducing identity already just to get this moving. And now what I have to do at this stage right here is some foiling. Okay, I'm going to have to multiply this one out because this particular problem asks you to fully simplify your answer. So this is going to be, let's see, I'm going to have a 4 on the bottom because 2 times 2 is 4. And then I've got some stuff on the top, which if you remember your foiling, we can move through this pretty quickly. This is going to be 2 cosine of 10 phi plus cosine squared of 10 phi. Okay, well that's all fine, except you can't put this in as your answer because you haven't finished getting rid of all the exponentials. There's still a cosine squared, and that's going to require more power reduction. I'm talking about this guy right here. That thing is not fully reduced yet. So we're going to keep on moving with this, and I'm going to rewrite this a little bit just for my own sake, and you might prefer it this way to better keep track of things. But look how I'm going to say this. I'm going to say 1/4 plus 2/4 cosine of 10 phi plus 1/4 cosine squared of 10 phi. Okay, it's the equivalent statement. But what this allows me to do is just make it a little bit easier on the eyes when I want to deal with that power reduction formula on the very right-hand side of this equation. This is going to turn into 1/4 times a bracket, and inside that bracket is 1 plus cosine of something divided by 2. Now what's the something? Well, it's twice the angle. So in this case, now we're up to 20 phi. See how those angles keep increasing? And if I want to fully simplify this, according to this particular problem, we're just going to have to keep on writing everything on the left the same and maybe distribute that 1/4. That might be helpful. It's going to turn into 1/8 plus 1/8 cosine 20 phi. You might be thinking, finally, we're done. Well, not quite. There's just a little bit left. We've got some more. If you take a look here, well, I lost control of my pen. So we're just going to combine the 1/4 and the 1/8. Okay, that's going to make a 3/8 plus 1/2 cosine of 10 phi plus 1/8 cosine of 20 phi. So that's why this weird answer looks why it does. There's a lot of algebra and combining like terms going on.